Most Claude Code videos show you a pretty clean workflow. In this one, I'll do something a bit more realistic. I'll train a machine learning interatomic potential using MACE by using DFT data from the one cluster and moving it to another GPU cluster. I'll show you how Git syncing and keeping your Claude.md file updated will help you stay sane and hold things together when research workflows get a bit more messy and complex. I'm Tobias. I'm a third-year PhD student at the University of Oxford doing material science. And if you saw my last video on DFT calculations with Claude Code, this is the follow-up. Hopefully you enjoy it. Let's get into it. Okay, so the goal today is to train an ML model on this silicon structure. And rather than just on one silicon structure, because we can't train an ML model on that, we have multiple silicon structures where for each of them, the atoms are a little bit displaced. And also, as you can see, the shape of the unit cell is a little bit distorted. So we have slightly different environments. So for example, with the ML model, we could run some molecular dynamics. And we're going to use, of course, Claude Code to do that. Right, so we have 50 structures here, and I've already done some DFT calculations on those. So let's look at what the repo looks like. So the best way is probably to go through the Claude.md file, which is the context for Claude, and so also the context for you. We have the research goal that we want to train a MACE machine learning interatomic potential for silicon. So far, I've only used Archer for these calculations, which is the CPU cluster that I used. So there's some login info on that. Then there's the repo layout. We have the VASP inputs, which is just standard DFT calculation input files. Also, those same VASP calculations, VASP input files, but now for all the 50 different silicon structures. So these postcards are slightly different. Some scripts. One was to generate the 50 structures, and the XYZ file that I just showed you, and Slurm file to run all the DFT calculations. But those DFT calculations have already been run. We're starting from the point where we want to use those DFT calculations to train a machine learning potential. Okay, and then lastly, there's some syncing information on how Claude Code should sync to Archer using Git, and that Claude should also update its Claude.md itself, but we'll get to that later. All right, let's get to Claude Code. So these days when I'm coding somewhere by myself, I like to use a little dictation tool. So I use WhisperFlow. So for example, to say, are all the DFT calculations on the cluster already done? Okay, and now we can send that. While Claude is going to check that. Oh, it wants to use a skill that I made, which is the HPC-check. To check my high performance clusters. And so that's okay. That's a useful skill at this point. One thing that I should also maybe point out is I've customized my status line here. So on the left here, you see the directory that I'm working in. Here in the blue bar, you see the amount of context that is used. So that's Claude Code context in this conversation. And here, this green bar that I've added, which I find very useful, is how much of my token allowance I've used within that period, and also when it resets. So every 5 hours, as you might know, if you're on a program, the Claude Code tokens reset. And it's useful to know when that is, so you can schedule, for example, when you go for lunch. One of the things I've also found is sometimes when I know I'm going to use Claude Code a bit later in the day, at the very start of the day at 9 a.m., I type hi, just to get this 5-hour clock ticking, so it already resets halfway through the day. And then also my 7-day, so my weekly token usage. Okay, so Claude is checked, and all the 50 DFT calculations are done and converged, so that's good. So which means we can move on to the next step. Okay, for this next step, I use quite an elaborate prompt, which I'll go through slowly. So here's the prompt. I'm also with Shift-Tab moving it to plan mode, because it will be useful to write a bit of a plan before executing all this. And I think what I want you to focus on when reading this prompt is the different levels of detail we can use in giving Claude instructions. So first, I give a very high-level instructions of what I want overall to be achieved in this project. So we want to train the ML model now on the DFT data. I do that because I think it's important in the Claude.md that your model has context about what the overall goal is of your project or what you're trying to do, because that helps with writing all the scripts and actually executing all the little parts of it. So, and then a more specific instruction, turning the DFT directories that we have on Archer into one XYZ file that can be used for training by writing a Python script. That's already a more specific instruction. And then we want to do the ML training actually on a different cluster than where we've done the VASP calculation. The VASP calculations were on Archer. The ML training is on Arc, which is a GPU cluster. And at this point, Claude doesn't know about Arc's existence at all, which is why I tell it to clone the repo from Archer to Arc with those XYZ data that it's extracted. But I also tell it how to log in to Arc. So again, quite a specific instruction, and where the path for that repo is that I want Claude to clone it to. And in order to move my data from Archer to Arc, I just clone the whole repo. And this in general, this git syncing of the repo, I think is very useful when you're working on multiple clusters and trying to keep everything in sync. And it also makes it easier to control your whole project locally, which is the easiest to do with Claude Code. And then finally, once things are synced to Arc, we need to submit there the ML training script, which here I actually provide the highest level of detail for Claude by providing a sample training script. You could, if this is because I already have one, I have done these MACE MLIP trainings before. So if you think about how you would instruct a new student in your group to do this kind of task, then it would be helpful to provide the scripts that you already have as an example that it can adapt for the student's specific project, or in this case, my new project that Claude is doing. Because I could also just point it to the MACE documentation and the ARC documentation, and it can read the internet and try and combine those to write the Slurm script from scratch. But if I already have an example script that contains the specific modules that are useful on this cluster, where my Python environment is, the specific hyperparameters I want to use for this ML training, then that's a much more rich source of information, and it actually doesn't require me to use a lot of tokens to explain all that or to type all that out. No, I just pointed to a path with a good template that I already like. So that's the prompt. While that's working away on the plan, let me also explain a little bit more about why we use Git. So it is useful to sync between the different clusters, as we're doing now, but also, especially if you're using these coding agents to change your code or change your inputs for your simulations, it's very helpful to have a backlog. And with Git, you obviously keep track of all the changes that you do. And I find personally that before the agentic coding tools, I didn't use Git that much because I don't collaborate on projects with other coders very often. And to be frank, like just typing the commit messages, I often forgot. But since Claude can do that very easily every time it does a little change, it makes it very easy to go back in time. And actually, as a last benefit, once you've completed your project and you've got it published, it makes it very easy to share what you've done and to put it on your GitHub, which is good scientific practice, so other researchers can easily replicate it, but also it helps to build up a bit of a portfolio to showcase your coding skills. All right, that's it done with the plan. Let's actually have a read through it. Okay, the higher order goal, parse the DFT calculations, move them to Arc, and submit the MACE training. Exactly. First, writing the parse script. That looks okay. It's writing a training, validation, and testing sets. I'm happy with that split. then it's using my template to write the training script on Arc. That also seems fine. Here we see where the Git comes in, as I was showing. So first, it writes all the scripts that it needs to write locally, pushes them to Archer, clones them to Arc, and submits it on Arc. So that all looks really good. Yeah, and it will check on Arc whether the job is running. Okay, all looks fine to me, so let's just accept it and let it go for it. This is also one of the reasons why I like to use plan mode. Is it runs for quite a while to write the whole plan, then you can take some time to read through it, and then it also will run for quite a while again, implementing all the changes of the plan, which means that in the meantime, while it's running autonomously for quite a while, you can work on a different project, answer some emails, have a meeting, do whatever you need to do. And yeah, just have this longer stint of autonomy. This is also partially because I've changed my settings that Claude doesn't ask for permission as often. So you see for all the bash commands, it just runs them without asking me for permission every time. Of course, you need to be careful with these sort of things. But yeah, in my experience, this has helped me a lot in speeding up my work. And so far, I've not had any problem with it running commands that I didn't want it to run. So be careful with it, but you can give Claude more autonomy as you get more used to it. All right, it looks like it managed to do everything. So it parsed the 50 outcars, creating these training XYZs, cloned it to Arc, and submitted the job. Let's also check if all those files are there locally too. So if we now refresh it, we do have this parsing of the single points, but we don't have the XYZ dataset, only our starting one. So let's make sure we sync it locally as well. This is also a benefit. I don't personally know all the Git commands from the top of my head, so I just say things like sync locally, and in this case, I did know it will git pull. So what is on Arc and Archer should now also be here locally. And yeah, we see now there's this training data with 3 different XYZ files containing the testing, training, and validation set. Okay, beautiful. So now while this ML training is running, we might want to work on something else. So, but before we close this session down, we want to make sure that the CLAUDE.md file is updated. Because your CLAUDE.md file is your context, and managing your context becomes really important because this is what always gets loaded as your starting point when you're opening up a new Claude Code instance. This is really what Claude knows about your project. So, for example, now we've added a whole new cluster. So I don't want to again explain how to log into Arc next time. I want it to still know that. I wanted to know that we're not still at the step where we've just finished the DFT calculations. We are now at the step where we're training the ML model. So it's important to update this. It is asked here to use a specific Claude skill that's especially made to update the CLAUDE.md file based on your current conversation. I've not made that skill specifically. This is one that Anthropic has made specifically for Claude. So let's see. Oh, that's a bit too far. Let's see what it suggests. It wants to update Claude with the new scripts, with the Arc details, exactly. So the login details for the new cluster, and also with the training job that's submitted. So it's adding all that information with the specific job ID. So next time we open a new Claude instance, it can check that very easily. And I immediately want to share something that I've also learned in updating the CLAUDE.md file. Especially when you work on a longer project, this CLAUDE.md file can become quite long when you keep adding and adding to it. So sometimes Claude will also warn you at a certain point that it has become too long. And that will reduce the performance of Claude, because every time you send a little prompt, your whole conversation essentially gets sent back and forth. This is what they call the context window. right? But even if I just say hi now, then everything we've said before, this 22% of the whole context window will get sent. And that context window always gets started with the whole Claude.md file. So if that already fills it halfway, then there's a lot of information that gets sent back and forth every time. And you'll see that you'll actually use up a lot of your tokens very quickly when you have a large Claude.md file, and hence a very full context window all the time. So this is why you also want to try and keep it a little bit trimmed down as your project progresses. And also why when you're starting to work on something a little bit different in the same project where it doesn't need the history of what we've discussed so far, you want to use prompts like clear. So you clear your context history and you start with a fresh CLAUDE.md instance that essentially only just loads the CLAUDE.md file, right? So this is why we've updated it now so that we can clear it and do the next thing from a fresh slate. All right, so now everything's been running for a little bit and we've cleaned up our CLAUDE.md. Let's look at how the runs actually went. And I tend to do that using weights and biases, or WandB, which is a common tool for tracking machine learning training. And we see here that some strange things have happened. So the validation, the error on the forces in the validation set, we expect to just decrease with the number of epochs quite exponentially, especially on a training set as uniform as we have, which is basically all the same structure, just slightly perturbed. But it stays plateaued at a very high value. And actually, potentially even more worrying is this graph on the very right, which is the losses, which is just 0 all the way through. So no wonder there's not much optimization happening if it thinks it's already perfect from the start, which it won't be, right? Because it will start with random weights. So we need to tackle that. So we can go back to Claude Code. And with our now clear slate, we can updated Claude.md so it knows what's happening. We could say, I think something's gone wrong with the ML training on Arc. The losses are 0 all the way through. Are the structures loaded in properly? Okay, so let's submit that. It again wants to use my skill. You don't have to ask again. That's the skill again that it uses to check the HPC queues, and it will see that the job is already done. Okay, so here we see the issue. The structures are loading, so it has the 40 training structures, but the validation structures aren't loading. So this is a bit strange. And if the validation structures are loading, then obviously the losses are 0. Okay, it seems like it's found the issue. So, yes, as we said earlier, the validation sets aren't being loaded in. This is because in the Python script that Claude Code wrote to extract the DFT calculations into an XYZ file, it labels the energies as energy rather than ref energy, which is what MACE needs. And apparently for the training data set, that still goes okay. But for the validation set, that causes issues. So what it now suggests is to fix basically the Python script that it wrote, to use the right keys for the DFT data, and then to rerun the training script. And this is where we also see that the Git tracking and the Git syncing that we've been doing, it becomes very useful because, this is a fix that needs to be done on multiple GPU clusters. And if we just say, yes, fix it, it can update the code locally, push it to Archer, run it there, pull the data again, update it on Arc, and rerun the script, rerun the MACE training script. So yeah, As you see, it's now updating the key, all the keys actually. I'm gonna change it to accept edits automatically. Yeah, and it's now doing what I said, pushing and pulling on Archer, reparsing the DFT data, pushing the data, resubmitting on Arc. All right, so it looks like it fixed it successfully, changing the keys that are used in the data set and rerunning it on Arc. So we also now want to update CLAUDE.md. Here, by the way, I type ;MD, which is just a little keyboard shortcut I use for CLAUDE.md because I type that all the time. Anyways, just a little trick. But we want to update CLAUDE.md with the new job number. This, again, how often you update CLAUDE.md is also a bit of a personal taste. I like to do it quite a lot and reset my context window quite a lot because that saves me tokens. And also in this case, actually, the specific ref forces, ref energy versus normal energy issue might be something that comes up more often. So it's probably useful to put in the CLAUDE.md file as well. All right, so it's fixed that, which means everything is in the CLAUDE.md file. So we can clear the context and maybe wait a few minutes and ask again how the ML training is doing. So let's wait. Okay, so a bit of time has passed. We can now look at the WandB curves, the weights and biases curves. Here, the green one is the old one, where the losses were 0 at the start, all the way through. And our purple one is the new fixed one. We clearly see that the losses start very high and decrease quickly, actually with a little step there. And also, if we look at the errors and the forces and the energies, they also go down. First, mostly the forces, because the weight is on there, and then the energies follow too. And even if we look at our final force errors and energy errors, they are much, much lower than in the failed run. So this one was much more successful. So we can also maybe check with Claude Code. Was the issue now fixed with the ML training? And if Claude Code confirms that too, then we can be even more sure. But in the end, obviously, trust yourself more than the AI. The AI can always make mistakes. So do verify things yourself. Nice. As we can see, Claude checked using the skill that the job was done, confirming the final errors in the validation set. And the losses are now non-zero, so it all looks good. And it actually, even without prompting this time, updates the CLAUDE.md file to say that this job is done, and with some final model results. This is the sort of thing where you can maybe store it somewhere yourself if your CLAUDE.md becomes way too large. So that sort of information that is not as useful for following runs is stored in your CLAUDE.md file. However, if, for example, you're testing different hyperparameters, then this actually might be very important information that you want to refer to time and time again. So again, how you manage your CLAUDE.md file depends on how you structure your project. But for now, I think because our CLAUDE.md file is still quite small, I'm okay with adding it to it. So that's fine. And with that, I think we've come to the end. So thank you very much for watching, and I hope you enjoyed it. As Claude Code confirms, the fix worked. Bye-bye.